In this mini lesson, I'm going to show you how to convert between scientific notation and standard form. We usually use standard form for most calculations. However, when we're dealing with really small numbers, so for example, 0.000078, or if you're dealing with a really large number, like 2,500,000. So just like 0.5 can be written as a half or 50%, those are different forms of 0.5. Scientific notation is just another way to write a number. When you see something written in scientific notation, you're only going to have a one-digit number to the left of the decimal place. If it's more or less than one digit to the left of the decimal place, it is not considered scientific notation. So this number that's in front on the left of the decimal should be one of the numbers 1 through 9. Then we'll have a multiplication here, and then we have 10 to the power of something. In this case, we have it raised to the -3. When you're looking at powers that are negative, that means it's smaller than 5.6. So you're going to move the decimal place to the left. When this exponent is positive, then that means it's bigger than 5.6. So you want to move the decimal place to the right. So this is telling me that 5.6 times 10 to the -3rd is smaller than 5.6. So we're going to write it like this. I'm going to start off with 5.6. 10 to the -3 would be 1 over 1,000. 10 to the 3rd is 1,000, and the negative tells you to flip it upside down, so it's 1 over 1,000. So really we're dividing by 1,000. And another way to divide by 1,000 is to just move the decimal place to the left 3 places. So we can look at whatever the exponent is. That will help us determine the number of places we have to move the decimal. So this is the starting place. I'm going to move it over 1, 2, 3. Here's where my decimal place goes. And then because I have blanks here, I have to fill in zeros. So 5.6 times 10 to the -3rd is 0.0056. Now, if you do this on GeoGebra and you want to take something in scientific notation and change it to standard form, so I'm going to put 5.6 times 10, and then I'm going to raise it to the power of, that's this button down here, and then I'm going to put in -3. And then I hit enter, and it gives me that number right there. 0.0056. Let's do another one. This one, in example 2, we have a positive exponent, which means when I see that 2.3, I know that that number is going to be bigger than the 2.3, so I got to move it to the right. So I'm going to start with 2.3. This is where my decimal place is, and this, because it's positive, the number should be bigger. So I'm going to move it 5 places to the right. 1, 2, 3, 4, 5. So this is where my decimal place should go. And then I fill in my blanks with zeros. So 2.3 times 10 to the 5th is the same thing as writing in standard form. Let's see, that's 230,000. Okay, so let's put that in here and try it. So I'm going to put 2.3, hit the times button, and then do 10 to the power of, so I'm going to use this button down here, and then 5. So you can see when we calculate it on GeoGebra, we get the same thing. Now let's look at it from the other direction. If we want to go from standard form and put it in scientific notation, this number is really small. So when we write our exponent, we're going to use a negative. And we always want to make sure that we only have one digit to the left of the decimal. So here I have 4.2. If I want one digit to the left, that means I have to put the decimal between the 4 and the 2. So now we're going to move this decimal place and count how many times I move it to get between the 4 and the 2. So 1, 2, 3. So that means when I write my exponent, it's going to be 10 to the negative 3. You can always go into GeoGebra and check it to make sure you did it right. So we're going to take 4.2 and divide by 1,000. That is why it's smaller than the 4.2. So let's check 4.2 times 10 to the power of negative 3. And we get 0.0042. So those are equivalent values. It's just written in a different form. Last example, we have a big number here, 54,000. I want only one digit to be to the left. So that means I'm going to put my decimal place right there. So I'm going to have 5.4. Now, even though it's not shown in this number, we know the decimal place for whole numbers is going to be right here. So I'm going to count how many times I need to move my decimal. So 1, 2, 3, 4. So this is going to be 5.4 times 10 to the 4th. And we're using positive 4 because this is a large number. We're going from 5.4, this part here, and we want to make it bigger so that it's equal to 54,000. So let's check one more time to make sure it's right. Let's see. I have 5.4. I'm going to multiply by 10 to the power of 4. So when we do the check, we get 54,000.